Good afternoon, good evening. This is Ankush here from Alif Consulting. Today we are going to talk about Azure Load Balancer. Now, going to the specifically to the Azure Load Balancer, first we need to understand why we need a load balancer and what is the importance of having the load balancer in the infrastructure. So, let's say you are running an application and that application is hosted in the back end on the three servers or on the four servers. So to use that four servers, usually initially what we had options to use the DNS round robin, which allow us to route the traffic on all the node, but that is not in enterprise level of solutions which we are looking for because it's kind of hit and run. So the request will be routed to the base on the DNS query. So that's the reason we need a load balancer. So what load balancer do? Load balancer allow us to route the traffic or distribute the traffic in all the nodes in the backend, and it monitors the health as well for the backend. So let's say in between the four VMs, there's a two VMs which has got issues and they are not able to run the application or they are not able to solve the application. So load balancer have those kind of capabilities where it can remove the server in between from the backend pool whenever there is a issue with the application or whenever the issue with the server. So that's something we can call a health probe which we can configure there. Now in the Azure we do have a service called the Azure Load Balancer. It's purely a software based load balancing. So usually we do have two types of load balancer, like a hardware load balancer and the software load balancer. So in Azure, with the Azure Load Balancer, it's purely a software based load balancer. It's a layer 4. It's work on network layer, and it's allow us to route the traffic to the multiple backend nodes. It's going to be a single point of a front end for the customer, and all the backends would not be visible to the users. The only the front end IP or the public IP or the private IP, whichever the load balancer we are going to create, will be only available to the customer or to the client to solve the DNS request. And with the load balancer, it also allows to have the high availability within the applications. As I told earlier, if you're running a multiple nodes in the backend, load balancer allows you to distribute the traffic and have the high availability in terms of running the application as well. And it's a fully managed service, so you just need to configure the your rules, your health props, and your backend. That's it. Rest of the things, routing the traffic or managing the health props, getting the health props, is something which will be taken care by the backend system. So it's a fully managed. Now here is the reason why we need a load balancer. So like having the high availability of the application or scalability of the applications, load balancing, like with the load balancer we can do the load balancing for our input and output traffic as well, and then it provides us the low latency and high throughput, and we can scale the application for serving the millions of requests as well. So where we can use the load balancer, like as I told, we can go with any kind of external and internal applications. So yeah, load balancer have internal and external both capabilities. You can use it with the internal network or external network as well. It allows us to increase the availability of your applications and distributing the resources in the backends. It allow you to monitor the health probe. It allow you to do the port forwarding as well. The port forwarding is the one of the important thing, because that is the something which we have with the load balancer, where we have like in a back end we are running a service on a different port, or in a front end we want to expose it to the different port. Then we do have a net capabilities within the load balancer which we can use. So I'll show you that in demo as well. And then we do have a standard load balancer, and then we do have the another thing like the port forwarding, multiple IPs or multiple ports. So that's something we where we can use the load balancer. Now here are some of the features of the load balancer, like the load balancing, outbound connection, automated reconfigurations, application agnostic and transparent. So it doesn't interact directly with the application. It's route the traffic based on the URLs and based on the backend configuration which we have configured in the load balancer. We do have a health probe and we do have a port forwarding. So these are the six features which we have with the load balancer. Now as I told earlier, like we have a two kind of SKUs for load balancer. So there is a few difference in between both. Like with the basic, we can have a 300 instance, but with the standard, we can have a 1000 instance running in the backend. Basic can only support the VM which is an availability set. So if your VM is in availability set, then only you can put those VMs in the backend pool in the basic. But in a standard, it's basically attached to the network. It's attached with your virtual network, so you can add all the VMs which is in the network. You doesn't require your the VM doesn't require to be in availability set to add in the load balancer. But if you need to have the SLAs, your VM need to be part of the availability set as well. So we have two types of load balancers, like as I told, public load balancer and the private load balancer. So public load balancer is basically used to expose your applications to the public network, and the private load balancer is basically used to expose your application is within the network. Now here is how the load balancer traffic looks like. So if you see in my case, I have a two tier of applications. My first tier is the web tier, and the second tier is the business tier. So business tier is basically hosting all the databases, and the web tier is the front end, which is basically required a user to access the information from the databases. So we have basically have a two types of load balancer here. We have a public load balancer and we have an internal load balancer. So public load balancer is basically exposed to the internet over the port 80. So all the requests from the end user or from the external user is basically coming on the public load balancer, and then to reach out to the backend tier or backend databases, the web tier VMs are using the internal load balancer to reach there. So that's how it can allow you to basically availability of the VMs, and it can allow us to basically have the high availability of the applications or services which is running on the VM. So this is, and it also help you to segregate the request to the all the nodes in the backend, like in a web. So if you have a three VMs, all the requests will be distributed to the all the three nodes using the load balancer. So this is how you can have a combination of public or internal load balancer, or if you want to use only public load balancer, or if you want to only use the internal load balancer, that kind of scenarios you can also use. Now let's move to the demo. So in demo, what I'm going to do, I'll show you how you can go ahead and create the load balancer, how you can configure the health prop, and how the load balancer will be going to route the traffic in case of any node is goes down. So let's move to the demo. So in my case, I have already logged in the Azure portal, and I have a two VMs running, VM1 and VM2, and both are the VMs are basically in the East US, and both of VMs are basically part of one VNet. So this is my VNet, and if you go here and if you go to the connected devices, we would be able to see this VM is part of uh, these both VMs are part of this network group, and both VMs are basically hosting applications. So if you click here, and if we go with this IP, so this is my one VM which is hosted with the one application, and this is my second VM which is hosting a same application or same IS page. So as of now, there is no load balancing in this both VM. So what I'm going to do, I'm going to create a one load balancer for these VMs, and we'll be going to route the traffic to the backend. So let's go ahead and create the load balancer. So as I told you, we have a two types of load balancer, like internal and external. We are going to create the external load balancer, and then we are going to choose the standard SKU. Since my both VMs is not a part of availability set, they are not a part of any kind of availability set. So I'm going to use the standard load balancer. I'm going to attach it to the virtual network. So let's go ahead and create that. So we can go here in the load balancer. We can click on create. Okay. Let's select the resource group. Okay. So it's going to be Alif demo LB is going to be the name, and Then we are going to select the USS, and then we are going to select the standard. So it also showing you to the use, it's also have the gateway SKU, but gateway SKU is most probably don't used in case of when you are basically using this load balancer for your applications, or exposing the application, or doing the load balancing within the application. So gateway SKU is only going to use when you are going to use some sort of NVA. So in that case, you use the gateway SKU. So I am going with the standard, and I'm going to use this as a public. And then we do have a two options, like how exactly do you want to use it. Either you want to use the regional, or either you want to use the global. So it allows us the load balancer with the global tier. It's allow you to route the traffic in between the regions as well. But in my case, I'm only going with the regional. Let's click on next, and then we need to add the front end configuration. So front end configuration is basically something where we are going to select, is it going to be v4 or v6, or what is the IP we are going to use it. So let's give it a name, VIP, virtual private IP. It's going to be IPv4. And then as of now I don't have any IP, so my both IPs are basically already associated with the VM. So let's go ahead and create the one more IP here, and let's put the name. All right, I'm not going to put this in any kind of availability zone, so click on OK. And it's not any kind of gateway load balancer. As I told you, that gateway load balancer is only going to be used in case of we are using any kind of virtual appliance or third party NVAs, or a third party WAFs to within our system or within our environment. So just click on add. Next, we are going to add the backend pool. So I'm just going to create the backend pool. I'm not going to add any kind of VM as of now. All right, I'm going to select the VM, and then configuration I'm going to use the IP, and that's it. I do have options to select the IPs here. So let me go ahead and open the tab, duplicate tab in the another tab, and let me grab the VM's backend IP. So that let's put that during the creation as well. Now one more thing is, these are the things which is there. You can put during the VM creation, during the load balancer creation, not a VM creation, sorry. And you can also do these kind of configuration once the load balancer is also configured. So in my case, I am doing it right now. And okay, so I don't know why this doesn't allow me to get the name here. Okay, IPv6, IPv4. Okay, let's add this as a blank, and we'll add it later on. Next, we are not going to create any kind of load balancer roles, inbound roles, or any kind of outbound roles. So, yep, let's do with the front end configuration and the basic backend role. So validation is clear. Let's click on create. So as soon as this load balancer is being created, we can go ahead and add our load backend pools, health props, and and the inbound rules to just route the traffic for the backend VM. So just let's give it some time. So it's usually going to take 2-3 minutes to get create of this load balancer. So you can see in the detail, the resources is being created, and now you can see the deployment is successfully completed and LB has been created. Now let's go back. Let's search for a load balancer on the top, and yep, we will be able to see we have a load balancer here. So if we go here in the load balancer, we would be able to see what is the backend pool, what is the load balancing rule, what are the health pro, what are the net rule, or what is the tier. So as of now, we only have a front end configuration. We are not having any kind of health backend health prop configuration. So let's go ahead and add the backend pool first. So I already have a backend pool. So let's select this one and okay. So it's giving me the error like there is no VM in the East US. Why? Since my case, I already have a VMs in the East US, right? So let's go back and figure out why this is giving us the error because I haven't selected the okay. All right. You can only test the VM in East ACS that's have a standard SKU public IP or okay. So I found where is the issue. So the VM which I have, they don't have a standard public IP SKU, I think. So let's see. Yep, they have a basic SKU. So I can go ahead and change this and okay. So let me go ahead and deassociate these IPs because I don't require them to be here. This is with the VM1. Let's go ahead and do with the VM2. So that's the basic thing. I forgot to mention here, when you have a load balancer with the standard tier, you need to make sure your public IP should be with the standard. So public IP SKU should be standard. So in my case, it's a basic. That's the reason it doesn't allow me to add that. So as of now, I have removed it, and let's go back to the load balancer and try to add if that's allow us to add. Else, we'll go ahead and have a public IP created with the standard SKU, and I will be able to add that VM in the backend for the load balancer. So, yep, it's going to be take a little time here. Okay, so both VM now doesn't have a public IP. And another case of not having a public IP is like I'll show you how you can do the NAT here as well. In that case, I will be going to expose the VM using the NAT and will be show you the use case when you are not having a public IP on the VM. Okay, so let's go back to the load balancer and health prop and go back. Okay, it's still showing is no VM. Let's select this one. Okay, and click on add. Yep, I have a two VMs. Let's add both and click on add. Okay, I think I might did a wrong. I should use the NIC here to add the VM. And all right, so let's go ahead and click on save. Before going to the save, you can see you do still have an option to use with the scale set. So not with the VM, but if you have a scale set, you can also associate it as a backend pool on this load balancer. So click on save. So it's going to take a few seconds to get this deployed. It's taking a little more time. It's still taking a time to add the VMs in the backend pool. So let's go back and see what's happening here. So when you refresh, we would be able to see the resources here. Yep. So you can see, I can see both VM is now showing here, although the deployment is still in progress, but I can see the both VM is part of the backend pool. Now, next step is going to be the health probe. So yep, now the successful deployment is also completed. So let's move on. Next part is going to be the health probe, through which the health probe, the load balancer is going to be monitor the backend VM. So let's click on add. Let's define the name, Alif demo health probe, and it's going to be on the HTTP. It's a default. I'm going to use on a pod 80 because my backend application is running on a pod 80. The default path is going to be backslash and then intervals and the threshold values. So these threshold values and these intervals can be increased based on the requirement. So what this means is in every 5 seconds, the load balancer is going to send a health probe request to the backend, and if there is more than two unhealthy threshold is there, or there is a more than two health two interval where health load balancer doesn't get any request from the backend server, that backend pool will be get removed time being, until unless the load balancer get a healthy threshold response from the backend server. So let's click on add. So it's still going to submit the deployment, and deployment is in progress right now. So we can go ahead and go back, and if we refresh, we would be able to see the prop. Yep, we would able to see it, but still it's in the deployment state. So we need to wait till the deployment is get completed. All right. So deployment is completed. Now next step is going to have it with the create the load balancer role. Now click on add, define the load balancer rule name. So in my case, sorry, rule. Front end IP is going to be the public IP. The backend pool is going to be the pool which I have created. Okay, so it's going to be on a port 80 in a front end and back end. I don't have any kind of customization here. So if I need any kind of customization within a port, I can define here where I want to expose the front end on the different and the back end on different. And HTTP, TCP reset, I'm going to disable it. Floating IP, I'm going to disable it. And outsource is going to use it to keep as it is. So that's it. And floating IP is something which basically we use with the uh, when we are going to have the SQL load balancer. So that's it. We just need to click on add. And we just need to wait for get this deployment completed. And post that, I'll show you what are the changes is basically happen on the VM, or what are the things which basically you see on the VM as a change when you add the VM in the load balancer. All right, the deployment is get completed. Let me show you the change which happened on the VM. So I have another tab open. So if you go to the overview, you would see your VM is now having the IP, public IP, which is associated with the load balancer. So both VM, which is a part of the backend pool, will be going to get the same IP, which is the load balancer. So if you click on this IP, And if you go to the overview, you would be able to see this has been associated with the load balancer. So that's the change happen on the VM side. And now let's go ahead and see what's happened with the our website when we browse through the load balancer. See, it's going to the demo 2, and if I refresh it, it's still going on a demo 2. So this will be going to route the traffic in between the VMs. Let's say our VM2 is got stopped due to the certain reasons or due to the some reason. So let's stop it. Now after that, you will see as soon as I hit again on this URL or this public IP, this will be traffic will be routed to the demo VM1. So if you refresh, it's still going on at VM1. So let's wait for a few seconds to get uh, this VM deallocated, and then threshold to be get unhealthy in for the backend pool on the load balancer. Then this route traffic will be this route this request will be routed to the VM01. It's still going on a VM01 because it's in a cache. Let's open the another tab, and all right, it's still going on a VM02, maybe due to the cache. So let me open the new window here, and all right, this is still going on a VM2. Interesting. No, this is coming from VM1. Okay, so if you see here, this is coming from VM1, and all right, and this is might also be coming from VM1. Yep, this is coming from VM1. So maybe I have put the same picture on the both side. But if you see here, this message on the top, this page is coming from VM01. Now let's go ahead and start this VM and stop my the VM1 which is here. So you will see this message is basically get changed. This message will be get changed to this page is coming from demo VM2. So let's wait to both VM to get swipe with their status. So my VM01 is going to be stop deallocated. Sorry, yeah, my VM01 is going to be a stop deallocated, and my VM02 or VM2 is going to be showing as a running status. So yep, it's in a running, and my 001 VM01 is in a stop deallocated mode. So let's refresh this one and see. Now this message has been changed. This page is coming from the VM 2. So that's how load balancer allow you to route the traffic or allows you to provide the availability or scalabilities within your application. Now if you need to add more VMs in this load balancer, it's just a pretty much straightforward. If you want to use same set of health probe or same set of rule which we configured, we just need to go in the backend pool. We just need to click on backend pool here, and we can add, or we can create the new load backend pool as well. Now another thing is we would not be able to add the VMs in the existing load backend pool because of the limitations. So what we can do, we can create a new backend pool. Here we can add all set of VMs which we require to be a part of a backend pool. Now it doesn't mean like if these are the VM already part of our existing backend pool, they cannot be part of the another backend pool as well. They can part of the multiple backend pool as well in the load balancer. And then once your backend pool is being configured, we can simply go ahead in the load balancer, and then we can change the backend pool from here. So that's how you can change or you can add a more server in the load balancer. Now let's move to the net rule. So net rule become a very important when you specifically don't want to expose the ports to the internet, and you want to use a separate port to expose a specific service. Example, RDP or SSH. You are having a VM and you don't want to have a public IP on the VM, and you want to take the RDP or you want to take the SSH of that VM to the specific public IP or over the different port. In that case, net rule become easy. or net will become a use case. So in my case, I don't have any public IP associated with this VM. This public IP is coming from a load balancer. So I can go ahead and have a net rule created from here. So I can go ahead and add the net rule, and I can define the name net rule RDP. I can define what exactly the public IP is going to be or front-end IP is going to be. I can define the service for for which service I'm going to use this net rule, or I do have a plenty of other servers, so I do have options to add the custom option as well, where I can define my port, and then I can use the VM for which VM I want to use this net rule. So I'm going for VM1. I need to select the network configuration and click on add. So as soon as you did this, you would be able to do a NAT rule over the 3389 port, and you would be able to access this VM over the RDP. So in my case, I haven't used any kind of custom port here. I just used the uh, port 3389 for RDP, but you do have options to use the custom port as well. So let's give it a few seconds. And then I would be able to take this VM RDP of this VM01 using the 3389 port with this load balancer public IP. Yep, this is done. So front end port is 3389. Let's try to take the RDPs. So in my case, I already have RDPs for this VM, so which I don't want to use. Same with the another VM02. So let's close both of them. And yep, I am going to add a PC. All right, and the public IP of that, and that's it. Click on add. So it's going to use port 3389 here to connect this VM. Uh, Most probably it would allow us to get connected. Okay, it doesn't allow us to get connected. Mm, okay, let me see. Let's give it a few more seconds here. Is it the correct IP? Yep, the correct IP is there. VMA01. That's fine. Oh, okay. Sorry, haven't used the port mapping. So either I can use this. That's fine. In the default, it's also going to be used 3389. But let's choose with the custom. So yeah. In my case, it doesn't allow you to get connected due to certain reasons which I need to troubleshoot. But this is how you can go ahead and have the net rule created. You just need to make sure you have a 3389 port open, which in my case is already open. So yep, that's how you can go ahead and create the net rule. Yep, that's what I have for demo. In the demo, we learn how we can go ahead and create the load balancer, how we can configure the load balancer, and how we can use the net rules within the load balancer. I hope you like this video. Please feel free to like or subscribe. Or in case of if you need any help, please reach us. Thank you.